Yeah, so question 21 is an interesting problem. So in this problem, we have an aquarium that has like a rectangular base that measures 100 centimeters by 40 centimeters and has a height of 50 centimeters. So the aquarium is filled with water to a depth of 37 centimeters. So for these kinds of questions, like these word problems, it might be a good idea to like maybe draw a picture just to help you visualize it better, right? So you have like your aquarium, like it doesn't have to be a great picture, just like a picture, right? That's like slanted. Okay, so like let's say you have like an aquarium, and let's say we know it's like, it's like a rectangular thing, and we know it measures 100 by 40, and it has a height of 50. So, like this length is height is 50, this width is 40, and it measures 100 by 40, and we're given that the aquarium is filled with water to a depth of 37 centimeters, right? So that just tells us that the aquarium is not like completely full yet because the capacity is 50 centimeters high. So it's gonna like come up to this like 37 centimeter mark, the water, right? So you have your like water here, and this length, this height here is going to be 37 centimeters. And we're given that a rock of volume 1,000 centimeter cube is then placed in the aquarium and completely submerged. So we want to know how many centimeters does the water level rise, right? So for this kind of question, like it's kind of like a word problem. It's kind of, you kind of have to use like logic, right? So when we drop the rock into the water, clearly the water level is going to rise, right? Because the rock is going to occupy space. But like the rock can't just like steal the space and just like, and the story ends. Like the water has to like rise up, right? So if the rock takes up 1,000 centimeter cube of like space, that means the water has to rise up, so that like it gains an additional 1,000 centimeter cube, right? So like let's say you drop a rock in here, that has like, a volume of 1,000 centimeter cube. We want to know how many centimeters does the water level rise. So let's say like the water level rises an additional height. Let's call it h, right? Just for another variable name. Let h be the height, the additional height that the water rises. Then we know that like if 1,000 centimeter cube rock is dropped in there, then the water level will have to rise such that the additional rise of the water would contribute 1,000 centimeter cubed of volume. So we know that like the base here is 100 by 40. So if the water level rises by a height of h, if it rises by like a height h, then like the water is going to rise such that the new volume that it like rises up to is going to be 1,000 or 100 times 40 times h, right? And this has to match with the 1,000 centimeter cube that the rock occupies, right? So this has to equal like 1,000. So like if we were to just solve this equation, we divide both sides by 100 and we cancel off two zeros. So you get h is 10 over 40, which is like 0.25 centimeters. And that would like correspond to choice A. And yeah, we would be done. So like, hopefully that made sense. Just to like summarize again, what we did basically was we first drew a diagram, because why not? And then we dropped the rock with volume 1,000 centimeter cube, and the water level rises up. So if the rock occupies 1,000 centimeter cube of space, then the water level has to rise up by 1,000 centimeter cube of space. So if the water level rises up at a height h by a distance h, then that means the water is going to rise up by an additional volume 100 times 40 times h. And that has to equal the volume of the rock, which is 1,000. So then we solve and we get like 0.25 centimeters.